Okay, 16, draw the graph of the function in the diagram below. So we need to find the zeros, which is at 3 and at -2. So when we substitute those into the function, we're going to have 0 plus 5. And we're going to have -5, so positive 5 plus 0. So at 3, we're going to have 5. And at -2, we're going to have 5. And now we need a point before, so we can do f at -3. So that's going to be positive 6, 7 plus 1. So at -3, it's at 7. You can, get an idea of it. If you substitute a -4, it's going to be at 7 plus 2, so 9. So you can see that this is linear with gradient -2. If you do f at 0, like in between, you're going to have 5. Okay, so it's consistent in between the -2 and the 3. Check it out. F at 2 is 1 and 4, 5. Okay, so then you need one after. So f at 4, which is going to be 1 and 6, 7. And you can see as well, if you substitute in 6, you're going to get 3 and 8, which is 11. So, it's up there. So then connect it with some lines, and that's your graph. Oops. So then the next one, and obviously this keeps on going. Write down the range of f. Since these keep on going, we have that the range is going to be y greater than or equal to 5. Express the function in the form f of x. Okay, so we want a piecewise function. So this part here in red highlighter, we already know the gradient's -2 because it goes down to over 1. And if we continued that, we would get y-intercept positive 1. Okay? The other way you can do that is pick a point and do y minus, let's do that point, 5 equals -2, x plus 2. So we're putting that point gradient form. And then solve. So -2x minus 4 plus 5, and that's where you get the positive 1. So that's for x less than -2. And then we're in between -2 and 3. So that's just y equals 5 there. It's a straight horizontal line through 5, gradient 0. And then after 3, we have the gradient is positive 2 because we go up 2 over 1. And you can see that the y-intercept is going to be -1. So hence or otherwise solve the equation f at x equals 9. So that's going to be here for x is 5 or x is -4. And the inequality f at x is less than or equal to 9. So we want from -4 to 5. Okay, so for this one, we've got the zeros are 3 and -2. So we need to substitute those in. So we're going to have -5 for this one. And -2, we're going to have positive 5. And we can go ahead and connect those because they're consistent in between there, and you can check it out. If you substitute in 0, we're going to have 3 minus 2, which is 1 as we get. Now we need something before and after, so we can do f at 5 and f at -4. So that's going to be 2 and 2 minus 7, so -5 here. So at 5, it's -5. And at -4, we're going to have 7, 5, positive 5. So this is like that. So, write down the range. Well, it's in between -5 and 5. So express the function in this form. So we're going to have f at x, and before -2, it's equal to positive 5. After 3, it's equal to -5. And in between, we have gradient 2. Oops. So, sorry, -2. It's going down. You can do that from y2 minus y1 over x2 minus x1, or just counting. You know, you're going down 2 over 1, down 2 over 1. So, yeah, gradient's -2, and y-intercept's 1, and that's for in between -2 and 3. Okay, so hence or otherwise, solve the equation f at x equals 0. So when is y 0? We're going to have it here at 1/2. So x equals 1/2. You can also, because you know it's this part here, you can set it equal 0 equal to that section, -2x plus 1. So -1 divided by -2, 1/2. Okay? And solve the inequality, f at x greater than or equal to 1. So we have all the x's before 0 are greater than or equal to 1. All right, so now we want f at x greater than g at x without calculator. So find the zeros, or we can square this one actually. So we're going to x squared, and that's going to be 4x squared minus 20x plus 25, and 3x squared minus 20x plus 25, and factor, hopefully. So 5 and 5, negative. So x is 5/3, or x is 5. Open circle, quadratic. We want it less than, so it's in between 5/3 and 5. Okay, so for B, we have f at x less than g at x. Oh, sorry, h at x, sorry. X plus 4 over 2. So this one, I would do like this. Oops. And we can do the negative of that. But I would do them separately. So we're going to have negative x minus 4 over 2 less than x. And it's, well, here we can just multiply by 2, because we're not switching an inequality around. Add x. So x is greater than -4/3, and on this side, x less than x plus 4 over 2, multiply by 2, doesn't change the inequality, subtract x. So we've got x, we have to find the intersection here, 4 and less than 4, this way, and x greater then negative 4/3. So this is the intersection in between negative 4/3 and 4. And C, hence solve when is G less than F less than H. G is less than F here. And F is less than H here. So if we do that intersection, so 5/3, 5, 4, and negative 4/3. So we have, first of all, in between negative 4/3 and 4, and then we have in between 5/3 and 5. So the intersection is in between 5/3 and 4.